Bismillahirrahmanirrahim. Today we are going to show that the motion of mass spring system is also simple harmonic motion. What is mass spring system? To arrangement, we draw the diagram. Suppose we have a fixed support to which an elastic spring of spring constant K is connected. To the other end, a block of mass M is connected to the spring, while the block of mass M is at rest on a horizontal frictionless surface. At this position, the block is at equilibrium position because it is at rest, and the restoring force acting on the block is 0. That is, at this position, we can write that restoring force is equal to 0 Newton. Now, if we apply external force on the block and displace it through displacement x to position A dash, so the displacement is, let's say, it's x. So at this position, there will be a force opposite to the external force acting on the block, which will restore the block to its mean position O. This force is known as restoring force, and at this position, the block is still at rest, but when we release it, the block will start moving towards equilibrium position O under the action of restoring force. But it will not stop at this position and will move towards here due to inertia, and hence it will perform to and fro motion between these extreme positions. So it is clear that the motion of mass spring system is vibratory motion or oscillatory motion. Now we have to show that it is also simple harmonic motion. For that purpose, if we consider the spring as an ideal spring constant which obeys Hooke's law, then according to Hooke's law, the restoring force acting on the block is directly proportional to the displacement. So mathematically, we can write it as restoring force is directly proportional to x, or restoring force is equal to kx, where k is the proportionality constant, and it is known that as the stiffness of the spring or spring constant. Here, as restoring force and displacement are in opposite direction, therefore we include a negative sign with the equation, and hence the equation becomes as F restoring is equal to minus Kx. This is our equation 1. Now, as the restoring force produces acceleration in the block, therefore using Newton's second law of motion, we can write that the restoring force is also equal to ma, where m is the mass of the block while a is the acceleration that is produced in the block by the restoring force. Now, as we notice that equation 1 and equation 2 have equal left sides, so we compare these equations. By comparing, we get that ma is equal to minus kx. Now, to eliminate m, we divide both sides of this equation by m. So m cancels with m, while a equals to k by m into minus x. While the terms k and m are constant, because during the motion there is no change in the spring constant and the mass of the block, so this is the constant term. So we write it as a is equal to constant minus x. Now by putting out the constant term, the equal sign will change to proportionality sign, and our equation will become a proportional to minus x, which is exactly the condition for the oscillatory motion which execute simple harmonic motion. This equation shows that the acceleration produced in this block is directly proportional to displacement x and is directed towards mean position, that is, it is opposite in direction to the displacement, which satisfies the condition for simple harmonic motion. On this discussion, we can say that the mass attached to spring performs simple harmonic motion. Thanks. Now we are going to derive formula for the time period and frequency of mass spring system. To derive the formula, we take the equation as a is equal to constant minus x. So I will write it as a is equal to minus constant and to x. As in angular frequency, the constant term is written as 4 pi square divided by t square. So replacing the constant with this term, we get the equation as minus 4 pi square divided by t into x. And also we have derived the equation for acceleration as acceleration is equal to k by m into minus x. So putting this value as a is equal to minus k by m into x, here replacing the value minus k by m into x equal to minus 4 pi square divided by t square into x. So the similar terms which are x minus x cancel with each other, while it becomes k by m is equal to 4 pi square divided by t square. Now by cross multiplication between these terms, we get the equation as t square k equal to 4 pi square m. We have to calculate time period. So by eliminating k, we divide the term by k both sides. So t square k divided by k equal to 4 pi square m divided by k. K cancels with k, while t squares become 4 pi square m divided by k. As we are concerned to find the time period, so taking square root on both sides, t square root equal to 4 pi square m divided by k whole square root. It becomes t, while the square root of 4 pi square is 2 pi and square root m by k. So this equation, which is equation number 6 for our topic, represents the formula for the time period of mass spring system. In this equation, we conclude that the time period is directly proportional to square root of mass of the block. It wholly depends upon the mass of the block. If we change the mass of block by decreasing and increasing, the time period will also change. Now to find the relation for frequency, we take the reciprocal of equation 6. So by taking the reciprocal, it becomes 1 over t, while it will become 1 over 2 pi, and hence this equation will become this one, k by m. Now as we know that the reciprocal of time period is equal to frequency, so by replacing 1 over t by f, we get the equation as 1 over 2 pi square root k by m. Now this equation 7 represents the formula for the frequency of mass spring system. It is also clear from the equation that frequency will be proportional to square root 1 by m, as these terms k and 2 pi are constant. So frequency will also change by changing the mass of the block inversely with square root. That's all.